Welcome to the demonstration corner. Today we're going to talk about the transient hot strip method, which is a new addition method to the MP-1. Again, we're in the demo corner. So this method is available on the MP-1, which combines transient plane source, transient hot wire, transient line source, and a new method with this transient hot strip. So what I'm really going to focus on is what are the differences between transient plane source and transient hot strip, and why does it have some unique advantages. So when you look at transient plane source, according to the ISO 22007-2, one of the principal orientation is that your sample, it doesn't have to be round, but in each direction is approximately twice the diameter of the sensor, and the thickness is at least equal to or greater than the radius of the sensor you're using. And that's to allow, whether it's symmetric or asymmetric, single-sided, that's to allow three-dimensional penetration. So that's the typical bulk three-dimensional approach for a transient plane source sensor. There's orientations of that for measuring average values, anisotropic values, slab values, but they're all within that same principal measurement set. If you're limited by radial direction or diameter, you can orientate a TPS sensor so that it matches the diameter, or very closely matches the diameter of the sample you're testing. And in that case, whether it's symmetric or asymmetric, single-sided, you're measuring along the length of that elongated shape, a rod, whatever it might be. And of course, with different diameters of sample, we have different diameters of sensor. So that's transient plane source for the one-dimensional module. This is for three-dimensional. Transient hot strip are sensors that are square or rectangular. This one is 10 by 10 millimeters. We have other sizes that are longer and wider. And they give you abilities to measure larger samples that the advantage of measuring it larger is the sample's more natural, that dimension, or perhaps they're a little bit more heterogeneous, whatever it might be. We do have other dimensions. The one we're going to talk about today is 10 by 10. So in the configuration of transient hot strip, you have all the same capability to measure bulk values, anisotropic values, slab values, all the same orientation, but specific to the transient hot strip with a few unique advantages. So if your sample is elongated, so like this, and you orientate the sensor like so, your penetration depth in this case is the amount of distance from the edge of the sensor to the edge of the sample. So this is 60 millimeters. This sensor is 10 by 10 millimeters. So on each side of that sensor, you have 30 millimeters of penetration depth. The height of this sample is 13 millimeters. So whatever the smallest dimension of those three, so either side or the thickness, is the penetration depth you have. So looking at this as a bulk sample or semi-infinite body, we want to stay within the dimensions of the sample. But if your sample is this shape, of course, that's a very specific advantage. Because now we can look at two dimensions that give us more flexibility in testing a unique shape. So with this same sensor and the same type of sample, this is isotropic, but if the sample was anisotropic due to fillers or repeating layers, I would be measuring a in-plane thermal conductivity and a through thickness thermal conductivity and thermal diffusivity. So that gives us, when you're using the anisotropic approach with the transient hot strip, you have the advantage of now getting the two directions, but for a very specific shape. So if you have a sample, a plaque, let's say, and you cut a sample from this direction and a sample from this direction, and measure each of them, you can get all three directions. So that's under the principle if your sample has enough penetration depth through the thickness. But let's say your sample is very thin, but it's still a strip, but it's thin, let's say, half a millimeter to 3 or 4 millimeters thick, and you still have the ability to run transient hot strip, and the one of the dimensions fit one of the dimensions of the strip sensor. So in this case, 10 by 10, and this sample is roughly 10 millimeters. So as the strip gets bigger, we're hoping that the sample you're selecting is of a similar width to that transient hot strip. In this case, we're just using these examples. But the penetration depth on this sample is only 3 millimeters. Although maybe possible, it's a relatively difficult test because we want to keep our heat that we introduce within the dimensions of the sample like the bulk sample. But what we can run, just like the TPS method, we run slab, we can isolate the thickness and look at the heat propagation just along the in plane. So in that case, the sandwich is insulation. So we put insulation on one side, just like transient plane source. This is transient hot strip slab, and then a mirror of the bottom on top. So our configuration would be like that, and we would put this in the sample holder. We run that, and that would give us slab, but it would give us a thermal conductivity, thermal diffusivity, and specific heat along that direction for a thin material. So then you can do bulk, anisotropic on a bulk sample that has enough thickness. But if you don't have enough thickness, you can run transient hot strip for slab. So those are very specific advantages where if your sample does not fit well to a three-dimensional shape, because you're limited by one dimension, you can run transient hot strip. Or if you want to look at that third direction. So in this case, you'd have anisotropic this direction and through thickness. And in this case, you'd have anisotropic this direction and through thickness. You'd have all three dimension on samples that you cut from a bigger sample. So, and then you can run slab, which gives us the same capability to isolate directions, but on thin materials. So that's a little description on transient hot strip. If you want to get in contact with us and see the different dimensions of transient hot strip sensors we have, we can talk about your application. That gives you an example of why this hot strip is unique and very specific to materials that are of unique dimensions and size or direction that you want to be sensitive to. If you have any questions, let us know. We're happy to answer. Thanks for your time.